Hey, what's going on, everybody? We're going to solve this problem right here, and in order to do that, we're going to have to look at it like it's a related ratio or an equivalent ratio problem. And here, I'll show you what I mean. First off, we have to see what the problem's asking us to do, and that is to find the dimensions of Timmy's triangle right here. Now we know the dimensions of this one right here, so we just need to look at these two triangles, which are similar. So when two triangles are similar, it means that they're related by some kind of a scale factor. So if I have one triangle here and I have a bigger triangle here, it's going to be something like, let's say, twice as large, or if I was going twice as large is going that way. If I was going smaller, it might be half as large if I was going from the large triangle to the small one. Okay, so let's take a look at the dimensions of the original triangle. Here it says it's 6 centimeters tall and 8 centimeters at the base. Okay, so alright, now let's look at the area of that. Let's just find the area first. So the area of a triangle is equal to 1/2 of the base times the height. So 6 times 8 is 48, and we're going to take half of 48, which is 24. So the area of the smaller triangle is 24 square centimeters. Now, we know that Timmy's triangle has an area of 384 square centimeters. And we just found that the triangle he's going to make one similar to has an area of 24. Okay, so we've got two area ratios here. We've got the first area, which is 24 square centimeters, and we've got the second area, which is 384 square centimeters. Just check that. 384. Okay. So those are going to be related by some kind of a ratio, and to find that ratio, or that scale factor, remember, it can be a scale factor right here, which I'm also calling a ratio because 2/1 or 1/2. Okay, now to find that, I can just divide 384 by 24 and see what I get. Okay, so 24 goes into 38 one time. I multiply, subtract, carry down. 24 into 144. Okay, well, let's see. I'm going to guess that that's about 6 times. Alright, so I'm going to guess 6. Now I'm going to multiply 6 times 4 is 24. 6 times 2 is 12, plus 2 is 14. Okay, great. And I subtract. Alright, so the ratio is 16:1. That's the ratio of these two triangles. It's going to be times 16. Now, it's important to remember that that's the ratio of the areas of the two triangles. Alright, so now if I was going to multiply that out by 16. I'm just going to do this and show you why it's wrong. Let's say I take 6 and I multiply it by 16, and I take 8 and multiply it by 16. Okay, well, 6 times 16 is 60 plus 36, or 96. And 8 times 16 is 80 plus 48, or 128. All right. Now, if I multiplied 96 and 128, I would not get 384. That's pretty obvious, because 128 times 3 is 300 plus 60 plus 24. Yeah, so that's going to be way too large. All right. So let me show you what I mean here. Let's say that we had a small square, and that was proportional to a big square. Okay, now we can work out triangles in a second, because a triangle is just half of a square. Let's look at a square. Let's say that this one had an area of 1, and we had to find the larger area. Okay? So this one has an area of 1. It means it has a base of 1 and a height of 1. Okay? And we needed to find the base and the height of the bigger square. Now let's say that we multiplied it by a scale factor of 16. Okay? That would mean I'd have a side of 16 and a side of 16. If I multiplied 1 times 16, I multiplied 1 times 16. Well, 16 squared, times 6 is 36. That's 256. See, that's way too large. Alright, so what I need to do is I need to multiply by the square root of the scale factor. Okay? By the square root of the scale factor. Okay? So, the square root of 16 is 4. Now I'm going to multiply each of the sides by 4, which is our scaling factor. Alright, so if I do 1 times 4, I get 4. And the other 1 times 4, I get 4. And 4 times 4 is 16. Okay? Now you see that the area of the small one is 1 times 1, base times height is 1, and the area of the larger one is 16. Now you see that their areas are related by a scale factor of 16, or their areas are related by 16 to 1. Okay? And you see that their sides are related by the factor of 4. Okay, that's going to be the scaling factor. So let's look back up here. Okay? Now, instead of the scaling factor of 16, we're going to multiply by the square root of 16, which is 4. Okay. 6 times 4 is 24. 8 times 4 is 32. Okay? Now I'm going to multiply 24 by 32 and see what I get. Two times 4 is 8. And 2 times 2 is 4. 3 is 12. 6, 7. 768. Okay. Now wait a minute. 768 is the area of a square with a base of 8 and a height of 6. Well, rectangle. Remember, the area of a triangle is half that. So I have my 768 where I multiplied my base times height. 768. Remember, the area of a triangle is half of that. So I need to divide. Okay, so 2 goes into 7 3 times. 6, 7 minus 6 is 1. 2 goes into 16 8 times. Remainder is 0. 2 goes into 8 4 times. We see that the area of the triangle is 384 square centimeters. So we checked it. Okay? And now, to answer our question, we see that remember, the question asked us to find the dimensions, and we found it right there. The height is 24 centimeters and the base is 32 centimeters. Okay. Share, like, subscribe. Thanks a lot.